very first speaker, we have Alexander Bessman, who is the maintainer of PSLab FOSSASIA, and also he's a hobbyist hacker and Python developer and lead developer of PSLab-Python. Alexander, over to you.
All right, yeah, welcome everyone to this little workshop we have here. So the topic of today's workshop is how to get started developing on the PSLab. So this is not a workshop aimed at beginners, but rather at developers who are interested in potentially contributing code to the PSLab. So that means that this workshop assumes some familiarity with Git, Python, and C. So if you're interested in just sort of using the PSLab, getting some hands-on experience with that, then I recommend the following workshop immediately following this one at 10. Then we are going to look at a new feature of the PSLab, which is Wi-Fi connectivity. And in that workshop, one of the options is to use the Android app to connect to it over Wi-Fi. So then there's no pre-knowledge required of anything. But in this workshop, you will need to be a bit familiar with Python, C, and Git to be able to follow along. So anyway, I'm just going to start by briefly describing the PSLab software stack and architecture, explaining how it works, how do we get it to do the things that we want it to do. Then I'm going to go over how to set up the development environment for the Python library, PSLab-Python, how to set up the development environment for PSLab Firmware, and then we're going to move on to the hands-on exercise part of this workshop. So there are two sort of options. Yeah, I think you can do both. The two exercises are to both have the same goal. So there are some PSLabs over here which you can borrow for the hands-on exercise. And the goal of the exercise is to get the so there's no PSLab in that one. Are there actually any PSLabs in this? This looks empty. These are all empty. There are no PSLabs in this. Okay, wait, here are some. All right, okay, good. Brilliant. That's for just the wires and resistor thing and things, but so here's the PSLab. So on the PSLab, I'm not sure how well you can see this, but down here, immediately north of the SD card slot, is a RGB LED. The goal of the workshop is to get that to flash. That can be done using either Python or by adding some C code to the firmware. And yeah, those two parts are what this workshop is all about. So, like I said, in order to actually be able to follow along here, you will need to install some things on your computers. But first, let's go over the software architecture. So the firmware running on the device. Well, there's a lot of things going on in the firmware, obviously, but the sort of core to adding new functionality is this type def right here, which we call a command function. Since the PSLab typically receives commands over its UART bus, over serial, we have to do this kind of very generic input-output type system that we're looking at here. So for any given command function, the way it works is that some bytes are being sent over this thing right here. Represents a serial bus. It comes into the PSLab's transport layer, and the transport layer basically looks at the header that's part of the transmission and calls the appropriate command function. And then what happens is the transport layer just hands over whatever argument bytes came over the bus to the command function. That's this top argument there, along with the number of bytes in that array, of course. And then it's up to each individual command function implementation to parse whatever input arguments it needs from that byte stream. So that's something that you will need to do in the exercise. And then it can also return. I think that's possibly not correct. Actually, this is a little bit out of date. But anyway, so the return values here will not be needed in today's exercise. So this blink function that you're going to add to the PSLab does not return anything. So we don't need to linger on that. But yeah, so on the driver side in PSLab-Python, that also has a transport layer, of course. But that's really quite a lot simpler. Basically, you just sort of, you cook up whatever bytes it is you want to send it to firmware, and just push them over the bus. And then the PSLab does the rest. So the first thing we're going to do is to set up the development environment for PSLab-Python. So what you're going to need for that are Git and Python 3.9. So does everyone who wants to follow along have those things already? Or otherwise you'll get some time later to sort of to do that. Like I said, so since some pre-knowledge is assumed in this workshop, I'm not planning to really go over how to install those things. There's not really enough time for that. But once you have those things installed, what you're going to want to do is you want to clone the PSLab-Python GitHub repository. And then there's a branch in that repository which is called summit/blink/skeleton. That branch contains not a complete implementation of the exercise, but like some scaffold code, which you can use as a foundation to solve the exercise. And then, if you're familiar with Python, the way you normally work in Python is you work in virtual environments. So you want to set one of those up and then install the PSLab repository in editable mode, which is done like that. pip install -e dot current directory. Once you've done that, you will have PSLab-Python installed. That's the driver layer. Then you can, we're gonna cover the exercise in just a bit. But let's move on to setting up the firmware environment as well. This one is a little bit more involved. So Git is also required here, of course, to clone the repository in a bit. But in addition to Git, to actually build the firmware, you will require a few other things. CMake is one. CMake is the build system we're using. You will need a make program, such as GNU Make. So if you're using Linux, you probably already have GNU Make, or you can install it easily. If you're using Windows or Mac OS, it might be easier for you to use something else like Ninja instead. But some kind of make program is required to be able to build it. And then you need the compiler. The compiler is XE16, so unfortunately we can't build the firmware using like standard compilers like GCC or Clang. That is because the microcontroller that we use in the PSLab is a microchip PIC, a PIC24, and that requires Microchip's own compiler, which is XC16. So that is something that you will need to install as well in order to build the firmware. So XC16 is a fork of GCC, like a really ancient version of GCC, like 4.8 or something, I think. And well, the current version of GCC is what, like 20 something. So really old fork, but since it is a fork of GCC, and GCC is itself like GPL version 2, that means XC16 is also necessarily GPL version 2. So it's technically open source, but it's really difficult to compile. I have not managed to do it, and I have tried quite a lot. So that's why you need to install it from Microchip's website. Yeah, so Microchip they want to sell licenses for this, which of course that's permitted by the GPL. You can sell it. That means that the free version that you can install from Microchip's website, that's a little bit you can't enable the highest optimization levels, O3 and OS. Those are disabled, but we don't need those, so that's fine. So once you've installed those things, then again, time to clone the repository. Same thing here. There is a branch called summit/blink/skeleton, which has the beginning of the exercise code, which you can use as a foundation. You will need to run git submodule init update. I think that's supposed to be 2 dashes, not 1. Dash update. That sets up a sort of CMake submodule, which is required for the build. And then you build it like that. You make a build directory and build it inside. CMake ... and then make. That should basically be it. Then you should have the firmware built. And once you have built the firmware, it's time to flash it. Of course, like this one that you build, it won't have the exercise implemented yet, so it can't blink, but you can at least see how to flash it. So flashing requires Python. That's why Python is required for also the firmware development. And then there is a tool called mcbootflash, which you can use pip install. And then you need to put the PSLab into bootloader mode. And you do that by pressing, so if you have a PSLab in front of you, you can go ahead and like sort of hand these. Anyone who wants to follow along here, just grab a PSLab. The PSLab has a button labeled boot and a button labeled reset. And to enter bootloader, what you want to do is you want to press the boot button, and while you're pressing the boot button, you briefly press the reset button, and that's going to make the PSLab enter its bootloader mode. And you will know that you were successful if the status LED starts blinking. Once that has happened, the status LED is blinking, you are in bootloader mode, and you can just flash the firmware, which by default has this name, PSLab-firmware.hex, using this command. So you select the port. On Linux, that's typically something like TTY USB 0. The baud rate is 460,800 in the bootloader. Once you're in application mode, it's 1 megabaud, but in bootloader it's a little bit less. That's basically it. So then we can move on to the first part of the exercise, which is to get the LED blinking in Python. So inside the repository, which you cloned previously, there is a file called blink.py, which contains the scaffolding code, which you will need to sort of extend to make it blink. There's a function there which is currently empty called blink, and your job is to fill in that function. The function takes a color and a period as input. The color is 3 integers in range 0 to 255, so 3 bytes, representing a color. So those are basically the channels red, green, blue for the LED, and then an integer representing the blink period in milliseconds. So that should be a uint16, an unsigned 16-bit integer. So Python doesn't really have a concept of integer sizes, of course, but yeah, any value up to like 65,000 is fine there. If you go over it, you need to add some checks to make sure that. Well, actually, I guess in Python it doesn't matter. You can use whatever. Python can do that. Anyway, then there is a function already in the PSLab and in the Science Lab class, which is the RGB LED. Read the doc string for that function and use it to make the board blink. There is a solution for this, which can be found in another branch. It's the solution branch, Summit Blink solution. If you get stuck, you can take a look at that. But this one shouldn't be any real trouble. I don't expect this to be very difficult if you are familiar with Python. Exercise 2 is to get the LED to blink using a firmware implementation instead. So in the firmware repository, which you previously cloned, there's a file called blink.c at that path. It contains several empty functions, one of which is an interrupt function. So that's sort of the interesting part of this exercise. So the thing with doing this in C is that it has certain advantages over doing it in Python. Now I'm sort of getting a little bit ahead of myself here, but what you're gonna see when you do this in Python is that since you will be constantly transmitting commands over the serial bus, the PSLab will be busy. You can't do anything else with it while you're blinking the LED using a Python implementation. But if you do this in C, you can use hardware interrupts to handle the blinking for you, leaving the PSLab available to do other things at the same time. So that's why, there's an advantage to doing this in C. An interrupt, if you're not familiar, is a function that runs in response to some hardware level change. And in the case of this exercise, that hardware level change is the value of a timer register, timer 1, reaching the value of another register, the period register PR1. Once those registers are equal, the timer 1 interrupt will trigger and run whatever code you put into it. And that code is then what should be actually causing the LED to blink. So interrupts can be used to perform asynchronous tasks, like I mentioned, leaving the PSLab available to do other tasks at the same time. So in the file blink.py, which was part of the previous exercise, there is already a complete function to call this command function in the firmware. But of course, that Python function, doesn't do anything until you finish implementing this in the firmware. So for this exercise, there's a partial solution under summit/blink/partial branch, in case you get stuck. And the full solution can be found in /solution, same as for Python. And with that, I'm going to leave you to work on this for a while. So, go ahead and feel free to ask me any questions if you run into trouble. And so let's see how much time do we have left. My plan sort of is to demonstrate this during the last, maybe say 10 minutes. So, yeah, okay. So we have 30 minutes approximately left of the workshop. So let's give it 20-25 minutes, and then I'm gonna just go over the solutions at the very end here. But now feel free to grab a PSLab and get to work. So these slides, you can find them at Eventjay, if you navigate to, if you go to the schedule and click on this this session, the slides are available there. I also recommend you reading the READMEs in the PSLab-Python and PSLab Firmware repositories. Those also have sort of the same instructions, but perhaps a little bit more elaborate. This is fairly condensed.